All right, so somewhere that you have space in your packet, the cover, somewhere on the back, I want you to think about this question. Ethan throws a basketball from the free throw line to try to make a basket. What type of curve does the path of the ball follow? Make a sketch if it will help you. We have an image down here of a student throwing a basketball, a kid. Pause the video now and write your answer. So you should have said a quadratic, or you could have said a parabola. If you were going to draw that as a graph, the ball would start here in his hand, it would go up and go towards the basket and then hit the ground. So now turn to page 57. We are going to talk about projectile motion and parametric equations. The formula H equals negative 16t squared plus v sub 0 t plus h sub 0 can be used to model the path of a projectile moving vertically, which is a y, and subject to the force of gravity. So if you think of that basketball, it's going up and then coming back down. The variable h represents the position of the object above the ground. 16 here is the constant, which is the force of gravity in feet per second, and t represents the elapsed time. V sub 0 will always represent initial velocity. V sub 0, you could also think of that sometimes in physics, we call it V naught. So it's either V naught or V sub 0. And H sub 0 represents the initial position of the object. So if Ethan is 6 feet tall and his hands are 4 feet from the ground, the initial height would be 4 feet. Using this formula, the vertical position of the object can be found at any given time. Most projectile motion is not strictly vertical. It uses a horizontal and vertical components. That's why if we use parametric equations, we can get both an x and a y equation, where x is the horizontal position and y is the vertical position. With an input with an independent variable of time. So here's our first example. Standing on the 20-yard line of a football field, you toss a football straight up. It leaves your hand, which is 4 feet above the ground, with an initial velocity of 50 feet per second. Assume that gravity is the only force acting on the football. Visualize the path of the ball as it goes straight up and describe the changes in velocity from the time the ball leaves your hand until it returns to the ground. So if I was going to plot a graph of this, let's say the person is standing here. Here's the ball. It's going to go up and then come back down. Since the motion of the football is vertical, the horizontal position x has to be a constant value. The vertical position will change. The following parametric equations will model the motion of the football. So we're saying, okay, the x position is 20. This is at 20 feet. The y position of the football is negative 16t squared plus 50t plus 4. So we're going to graph this in our calculator. So open up your graphing calculator. And we want to change the mode to parametric if it's not already in parametric. And then we need to deal with the window. So let's stop and think for a minute. The window, there's a window button, takes into account the input, which is the t, the x, which is the horizontal, and the output of y, which is the vertical. So let's start with t, which is time. T minimum is always going to be 0. We can't have negative time when we're having projectile motion. Balls, balloons, anything that's being thrown or tossed. T max for time, to think about how fast does the ball go in the air? and then come back down. You can say 5 seconds. I'm going to stick with 10 seconds because that's usually enough time, but not too much time. And then T-step is how often your calculator will plot points. The T-step, we're always going to do a T-step of 0.1. So every 10th of a second, we will plot a point. Now, in this specific situation for X, our person is only at 20. That's constant. So for X min, I'm going to say 0 so I can see my Y-axis. And then for X max, I'm just going to round up. I'm going to say I want to look over here to 30. The X scale is how often there's a slash mark. Let's go every 10. Y minimum is the ground. So you could say 0. If you have one of the newer calculators that graphs in color, you could say 0 and not have any problem. I'm going to make Y min negative 10 so that when I'm in my calculator in the graph, I get some kind of buffer down here so that, well, this one's the newer one where my print's at the bottom. But if you have the older kind, the print goes right here on the graph, and we want to give this white space below the x-axis so you can see what you're tracing. Y max, how high do you think that football can go? I'm going to estimate, I'm going to say 50. I'm just taking a guess. I'm using that based off the velocity. We'll see. If it's too big or too small, we'll fix that. And I'll do a Y scale of 10 again. All right, so now in our calculator, first I need to change my mode to parametric. I'm going to go to Y equals. I'm going to type in our equations here. I'm going to go to my window. So here's the window button, and I have to change everything. So T min 0, T max, I'm going to do 10 and then hit enter. T step is always 0.1. X min, no, S max is at 30 already. X scale, Y min, Y max, Y scale. And we're going to hit graph. All right, so here's the path of the ball. Kind of similar to what I drew there in my little sketch. Oops, sorry about that. All right, trace the path of the ball. So I'm going to hit the trace button. Every time we need to use these graphs for values, we're going to hit trace. So hit trace. I see T is 0, X is 20, and Y is 4, that initial height. And then we're going to use the right arrow to jump and trace every T. So the next input is 0.1, and 0.2, and 0.3. So you can see the T value changing and the height of the ball changing. I can see the top position of the ball, so I made my window high enough. As we do the next problem, we'll talk about how to determine what your window is. So as I keep hitting the right arrow, I can see the ball go up and then start to come back down. All right, so let's answer the questions. What do the displayed values of T and X and Y represent? So T represents time in seconds. X represents the horizontal position in feet. And Y is the vertical position in feet. So when we trace the display of T equals 1.5, X equals 20, Y equals 43, what does that tell us? So at 1.5 seconds, the ball is horizontally located at 20 feet and 43 feet high. Okay, when does the ball hit the ground? And we're not really going to change the t-step. It takes forever for the graph to calculate, to graph when you change the t-step. So we're going to leave it at 0.1 and get as close as we can to hitting the ground. So the y value is the height. So 5.24, not on the ground yet. 0.16, that's pretty close. -5. So when I trace, I want to pick the y value closest to the ground. So this 0.6 is closest to the ground. So when is a time? So the ball hits the ground when t is, right here, 3.2 seconds. All right, turn to page 58. Now we're going to include angles. So when you have, for example, the warm-up, Ethan with that basketball, he's going to throw the ball at an angle. It's never, no ball is going to go straight up and then straight back down. So for these problems that we have an angle, you're going to be given the parametric equation setup, the horizontal position for x, VO is always initial velocity, y sub 0 or h sub 0, that's the initial height, and theta is going to be your angle in degrees. So before we get any further, I'm going to go to my calculator, and in mode, make sure you're in degree mode here. All right, the left field fence of a baseball park is 400 feet from home plate and 8 feet high. The fence has nothing to do with the baseball being hit. So don't use the 400 or the 8 feet yet. A baseball is hit from a height 2 feet high. That's y0, with an initial velocity of 150 feet per second and an angle of 25 degrees. All right, so using these pieces, pause the video and write your parametric equations. So I got x equals initial velocity cosine 25t, and then y negative 16t squared plus 150 sine 25t plus 2. So the question is the hit a home run? So first, some information about baseball. If you don't know about baseball, when a ball gets hit out of the park or over the fence in the outfield at the end, looks like this. So if here's home base, if the ball is hit and it goes over the fence, it's a home run. And the runner, the player, gets to go around all the bases and gets to score. So if we're looking at this as a graph, the ball is hit. And what it's saying is if a fence is 400 feet away, so let's say here is 400, and it's 8 feet high, will the ball go over that 8-foot fence? So we need to get this graph in our calculator to see when x is 400, what will y be, and is it more than that 8 feet high? All right, so go to y equals. We have to type in our equations. And in my experience, the typing here is the hardest part for students. You have to type this in exactly the way you have it written. T's, the squareds, you cannot leave anything out. The negative down here by the enter button for the negative coefficient. So pause the video, you type your equations in and check them against what mine are. So I want you to check your equations to make sure they match mine. Once you get your equations typed in, I want you to press second graph. And my table is set so I can type these values in. I don't want that. So I'm going to go back to do second window, which is table set, change this back to auto. So that was second window for table set to change it back to auto. All right, so now I'm going to go second graph to get my table, and I want everyone to check before we do anything else. Pause the video. Is your, at T1, is your X 135.95 and is your Y 49.393? If they're not, go back to your Y equals and check the way you typed in your equations. So I'm going to use this table to help me set my window. Our T-min and our T-max and our T-step, they're going to stay the same. It's the X-max and the Y-max I want to change to fit this picture. So if I'm looking at my Y values here, I see the highest one is 64.785. Since that's the highest Y value, I'm going to make my Y max a bit more than 64. I'm going to round up to 70. Then when I notice the Y value gets negative, that's below hitting the ground, that's negative at 543 feet. So that's here, this point is 543 feet past the start. So if I make my X max, I'm going to round that up to 600. I'll be able to see this entire picture when I hit graph. So I look for where the ball hits the ground, look at the X value, and round that up for your X max. Okay, so I'm going to go to my window, change my X maximum to 600, and my Y maximum to 70. Graph. All right, so we can see the whole path of that baseball. I'm going to hit the trace button, and I want to trace over to where X is 400. So I'm checking out my X here. Oh, I went way past it. Okay, so 394, 407. They're both, well, this is 7 feet away. This is 6 feet away. So I'll use this one. So 394 is as close as I can get to 400. The Y, the height of the ball is 51 feet. So when X is 394.24 feet, Y is 51.28 feet. If this fence is only 8 feet high, 8 feet, does the ball at 51 feet go over the fence? Yes, it does. So when X is 394, Y is 51, which is higher than 8 feet. So the home run is hit. Well, wait, the hit is a home run. All right, let's try number 2. An arrow is shot from a bow 4 feet above the ground at an angle of 10 degrees with an initial velocity of 200 feet per second. So pause the video here and write your parametric equations. Okay, check your equations with mine. Initial velocity is v sub 0, 4 feet is h sub 0, and 10 is our theta. All right, calculator time. We got to type these in. All right, let's check your typing. Go to your table and pause the video. Does your x at 1 equal 246.2 and your y at 1 equal 31.412? If not, go back, check your typing. Do you have all the t's in the right spot? Do you have all the plus signs? Is x cosine? Is y sine? Double check your y equals if your values here don't match mine. Okay, if they do match, let's figure out our window. I need to look at my x max and my y max. So for x, let's do y max first. The highest y value I see is 31. So for y max, I'm going to round up to 40. The arrow hits the ground here at -9. That's below the ground. And that happens at 738 feet. So I'm going to round my x max up to 800. Window. Change the values we just talked about. Hit graph. And there we go. Here's our arrow's path. Find the amount of time the arrow is in the air. So the time it hits the ground, the time the arrow hits the ground is the amount of time it would be in the air. So we're going to hit trace. And I got to trace over here to the right-hand side to see what time that happens at. So look for your y value. Get as close to 0 as you can. This one's the closest to 0. So the arrow is in the air 2.8 seconds. Find the horizontal distance the arrow travels before it hits the ground. Okay, so over here when it hits the ground, the horizontal distance is 689, round to 2 decimal places, 37 feet. All right, one more, the maximum height. So that's the vertex up here. I'm going to trace back to the left and look at your y values. So the highest y value as I check out the top here is 33.42 feet. Okay, so for sake of time, we're going to skip numbers 3 and 4. And, whoops, moving the wrong thing here. And we're going to, on page 59, skip down to number 5. We've got Jack throwing a ball off the roof of a building, 300 feet high with an initial speed of 100 feet per second and an angle of 45 degrees with the horizontal. Pause the video here and see if you can do the whole problem. If you get stuck, unpause, watch the part that you get stuck on, but pause here and try the whole problem. All right, so your parametric equations, x equals initial velocity cosine angle t, y equals -16 t squared plus 100 sine 45 t plus 300. All right, I'm going to go to my table, figure out my x max and my y max for my window. So the highest y value here is at 377. I'm going to round y max up to 400. -158. So that's way below the ground. That happens at 565. So I'm going to round that up to 600. Window. Oops. Right, so starts at 300 feet on the top of that building, goes up and comes down. How long is it in the air? I'm going to trace to the ground on the right-hand side. Oh, so 10.9 or negative 4.5. That one's closer to 0. So the ball is in the air 7.1 seconds. That happens 502.05 feet. And the maximum height, let me go back up to that vertex, is 378.12 feet high. Is that the only? Okay, that's the last piece of that question. So your homework is page 60. I think it's just 2 questions. Oh, just 1 question. And I'm going to include the answers here in the video. That way you can pause and check if you'd like, or you can look up your answers in Drive.